All right, so I am really excited to introduce our next speaker. Our next speaker is going to talk about abstractions, and we all know that abstractions can be also really tricky to know when to introduce an abstraction and what the qualities are of a good abstraction, because sometimes we can kind of paint ourselves into a bit of a corner, but sometimes a good abstraction can really make us really productive. Our speaker, he is an iOS freelancer in New York City. He's also one of my favorite bloggers. He's blogging at Khanlou.com. And if you've ever used a coordinator pattern, which is really popular, you have this guy to thank for that. Please give a very warm welcome to Soroush Khanlou.
All right, hi everyone. I'm Soroush. So today we're gonna have a talk that's very heavily focused on art. We're gonna be talking about the story of this bull, but we're also gonna be talking a ton about code. So really strap yourself in because there's 200 slides of code. Yeah, we're gonna get serious about this. So this is a class. This is a class I really like. There's some promises here and some generics here, but you don't really have to know what they do. They just make the code a little bit shorter. Let's run through what this code does. First thing it does is it takes some object and builds an NS URL request out of it. It sends that URL request, it gets a response back, checks the status code, and if it falls outside of a certain range, it will throw a status code error. And lastly, it decodes some JSON. So this is a network client, right? And I really like this class. I think this is a really great class. Why do I like this class? I like this class because it's testable. Things that are testable are really good. So how do we know that this class is testable, right? Well, there's a couple different ways we can look at it. One thing we can look at is how many singletons do we have here, right? And we have exactly one, and that's the URL session. So if we wanted to come along and test this class, all the code is just code. The singleton that throws a monkey wrench into the testing, we can wrap in a protocol. We can inject that into the initializer, and then all of a sudden we have this class and all this code that we can test. So that's like one element of why I like this class. It's very testable. Another way we can look at how much this code is doing is this big fancy word. It's called cyclomatic complexity. And what cyclomatic complexity represents is how many branches does your code have, right? So this class that we're looking at here, how many branches does it have? Well, let's walk through it. So we've got the first branch, which is the happy path, right? So this is just everything goes normally. So you create the URL request, you send it, you check the status code, seems fine. You decode the JSON, it's fine, and you have a success. So that's one branch. You have another branch here, which is what if there's a network error, right? You create this URL, request, and you pass it over to the URL session, and that has some kind of error, and that is where the branch ends. So that's the second branch. There might be a third branch here as well. So again, create the URL session, send it, check the status code, but this time status code fails. So that's another branch we have here, third. And the fourth branch we have in this code is what if the JSON parsing fails? So again, create the URL request, send it, check the status code, try to decode the JSON, and then fail. So this code has 4 branches. 4 branches is a very small amount. Roughly each branch is one test. So you know that with 4 tests, you can test every single line of code in this class. So that's another reason that this class is really good. Now, as much as I love this, the sad truth is that no code that's good gets to stay good, right? There's always going to be something that changes. Somebody's going to come along and ask you to add a new feature, right? They're going to say, well, our API is good, but we really need authentication in our API. So you say, okay, well, I'll just add that real quick. I'll just throw that in there. Not a big deal. And then, somebody else comes along and they say, well, we actually need, our URL requests are dying in the background. We need them to stay alive, so we need background task identifiers. So you go ahead and add that code. And you need to make sure to clean that up when you're done as well. And then somebody else comes along and says, well, on iPhone X's, you're a developer using iPhone X, but you don't have the network activity indicator. But I do. I have an iPhone 8. I need the network activity indicator. So you build a request counter, you increment the counter, you decrement the counter. And our code that was so beautiful before has become this tangled mess, right? And so what happened here? What went wrong with our beautiful class and made it so frustrating to work with? So again, there's a few ways we can sort of look at what went wrong here. One approach is we can look at the single responsibility principle, right? Before we had one tight responsibility, which was send the request, get a result, parse it, done. Now it's a little bit more messy, right? There's this auth token stuff, there's this background task stuff, there's this request counter stuff. So these are all these extra responsibilities got thrown in here and made the thing much more complicated. Another way I like to look at, like, is this class too much, is some people will say this is too simplistic, but I just like looking at the line length. How many lines of code is it? You can really easily see it's not as nice as it was before. There are other really cool ways to look at like how complex a piece of code is, but honestly, 99 times out of 100, line length tells the whole story. For that one time out of 100 that it doesn't, we can go back to cyclomatic complexity, which we looked at. And I'm not going to run through all the branches, but I will take a broad look at them. We have 2 up here, we have 2 here, 3 here, our original 4 that we had, and another 2 here. So there's a lot of branches, but they also combine, right? They're not just by themselves. And does anybody know how they combine? How they come together? How all these numbers come together? Anybody want to throw something out? Multiply them, that's right. So you don't add these up, you multiply these. So if you actually want to test all this code, you have 96 different branches, which means 96 different tests if you really want to be complete with this class. So this is another way to see that this code that was so nice became so complicated. And again, we can also look at our singletons, which we looked at before. We had 1 before, we have something like 4 now. So, we added just a couple features, but each one needed this piece of global state that it needed to talk to in order to make its stuff work. And so we can do the same thing as... All right. There we go. So we can do the same thing as we did before. We can take each of our singletons, kind of pull them up to the top of our class, and then we can sort of, once we've pulled them all to the top of the class, we can wrap each one in a protocol, and then we can kind of create an initializer. This is horrible. You don't want to live like this. You don't have to live like this, right? You deserve better than this, okay? So what do we need for this? We need to learn how to abstract code, right? But of course, it raises a question, why do we want to do this now? Why didn't we do this earlier? Why don't we do it later? And so the reason that we look at this now is one, we're feeling the pain, right? This code is starting to get unmanageable. It's starting to get untestable. We haven't tried to abstract before we know what we're working with. We really have waited until we've seen the problem. We've also kind of hit this complexity threshold where it's starting to get a little hard to understand this class. It doesn't really fit on one screen anymore. Another thing you look at is kind of this rule of 3. We've added 3 things. Maybe we can start to break those up. And so that's why we want to look at this now. But before we go on to how to abstract something, I want to look at our friend the bull. It's a famous lithograph. It hangs in Paris. I don't think it's hanging right now, but it's on display sometimes at one of the museums there. And the bull, as it gains shading, it becomes very interesting to look at, but it loses the sense of what it means to be a bull. Right now there's a lot of shading and a lot of complexity, but what is the real bull that's underneath this, right? So that's sort of why we want to look at this thing now. The thing's starting to get complex. Shading is getting out of control. So we want to look at how to do this thing, right? How do we abstract our code? So to abstract code, I have this kind of several-step process that I like. It's a little fuzzy, so just go with me. But step 1 is going to be to find any similarities that we see in the code that we're looking at. So we can kind of break the code up in a couple of ways. We can look at it, we can break it up by slices of time, right? So we can say, well, this chunk up here, this is like headers. So this happens way before the request gets sent. It can happen any time before the request is sent. So that's like one time slice, distant past. One time slice is right before the request gets sent, right? We need to increment the counters, and we need to get our little UI background task. That's right before we send the request. Then we have this other slice of time that happens right after we receive the results of the request. So these slices are pretty useful, so maybe we can kind of break these up into their own little objects and then kind of hide that code away. But we quickly run into a problem, which is that the background task identifier relies on this piece of state. This UI background task identifier needs to be handled in both the before section and the after section. So then we're going to have to pass this piece of state around, and it's just going to get messy. And maybe if you're passing all this stuff around, there's a smell that you're not encapsulating your state well. And so maybe there's another way we can slice up our code, right? So we looked at what it's like to slice up our code by time. What if we looked at the responsibilities that we discussed earlier, right? So we have our auth token responsibility, we have our background task responsibility, and we have our request counter responsibility. So these 3 responsibilities, we can kind of break them up into their own little objects, and we can kind of pull the code out, and we start to see that This doesn't run into the same state problems. All the state is sort of encapsulated in one of our custom classes. And so we know that this can actually work for us. So that's sort of, we want to take a look at the different slices of the problem and break them down and figure out like how we can decompose this problem. And back to our bull. The artist of our bull begins to feel a lot of pain with the complexity of the shading of this bull, and starts to find the lines that represent the true meaning of the bull, and begins to draw those out. Right. So step 2 in our process, we need to start developing the abstraction. What is this actually going to look like? Right. And so here's our same code, zoomed it a little bit so we can actually read it. And we notice that our 3 time slices that we looked at before, they're still there. Right? We have our headers, we have our before code, and we have our after code. So this little decomposition that we did earlier could actually still be useful. So what if we sort of rename these methods that currently are in the domain, like their increment or release, we rename those methods to be what time slice they represent, right? So we know that our header code just needs to say, like, well, add these headers. Our before code can just get replaced with a function called before, and the same with our after code. And once we've done this, you can kind of see that there's really only 3 methods here. And these 3 methods kind of naturally fall out and form a protocol. And so you can say, well, I have this sort of side effect that I need to happen before the request gets sent, maybe after the request gets sent, maybe I need to add headers, whatever it is. And so this side effect concept represents each of those things that we're doing, right? I think side effect is a little too specific. I want to make it a little more abstract here. I'm just going to call it a behavior. This is a thing that we want the request to behave like. And so once we have this protocol, we can look back at our original code, and we see that our objects at the top, they actually can conform to this request behavior protocol really easily. And so once you've done that, and this is the whole crux of the thing, right? You have these 3 variables that have the same type. They can all be treated exactly the same. So why don't we treat them all exactly the same? You can drop them all into an array, and this is really the magic step. You're taking many different things and treating them as though they're the same thing, right? And of course, once you have that, then you can do some of the same injection stuff that we were doing before. And now, any network client can handle any set of request behaviors. And that's really cool. So I'm going to rewind this a step and go back to this. Once we have code that looks like this, the body of our function actually no longer deals with the specifics of what behaviors it's looking at. It just deals in just this array. So I'm just going to add the headers for all of them. I'm just going to run the before code for all of them. I'm going to run the after code for all of them. So our code no longer has to know about all the specific details about all the little behaviors that it works with. Cool. So now that I've got this protocol in mind, I think I can work with this, but I want to tighten it up a little bit. There's some things about it I don't like. First, I don't actually want to deal with URL requests at this level. The request behavior doesn't need to know that there's a URL request. It just needs to be able to provide me with some headers. So that's easy. And before and after, they don't really mean a lot, right? When you're conforming to this protocol, you're going to have a method called before. Before what? Before send, right? It's before we send the thing. And after has the same problem, but after also has an additional problem. It can only abstractly handle success or failure. So what if we want to be specific about that? We can separate that into 2 methods, one that gets called in each case with the relevant data that we care about. One more little thing I want to add here. One of the really cool things about this protocol is that every single part of it has a really nice default. So additional headers, no headers. Before send, do nothing. After success, after failure, do nothing. And so these kind of make sure that we don't have to implement things at conformance time that we don't care about. And so that makes it a little bit easier to use this protocol, right? So that's step 2, develop the abstraction. Like, what are we actually dealing with here? And our artist who loves the bull, continues the refinement process and continues to pull out the major lines that define what this bull is all about. So at this point, I want to stop and I want to talk about this little phrase, don't repeat yourself. Don't repeat yourself is a phrase that we learn really early in our careers. And we learn it early in our careers, I think, because it's a very simple thing to understand. If 2 pieces of code look the same, make them be the same. So when you go to change it, it's really easy to change. But the thing is that don't repeat yourself doesn't solve the problem that we are trying to solve here. None of the code really looks the same. We're finding common structures here rather than common chunks of code, right? And then we're factoring them out into sort of common shapes. Don't repeat yourself is kind of a good first approximation, but as you develop more in your programming career, you need things that are more subtle and more refined. And so I think it's worthwhile to look at this sort of chart. If we have sort of similar code and dissimilar code, and we want to look at how that's the same and different from similar underlying concepts and dissimilar underlying concepts, right? So if the code doesn't look the same and the concepts are not the same, that's actually very easy. That's most code. You don't need to worry about it. If the code looks the same and the underlying concepts are the same, then somebody's already probably abstracted that because the code looks the same. That's fine. If the code looks similar, but the underlying concept is not the same, this is where you're in trouble, right? When John mentioned that how hard it is to abstract and how easy it is to paint yourself into a corner, this is it. You pull the code out and you deduplicate the code, but the concepts under the hood really were not the same. And so as you try to make this thing behave in many different ways, you end up feeling really hurt. And then the last quadrant is when the code doesn't look the same, but the underlying concepts actually really are the same. And that's what we're dealing with here. And this is where you can provide the most value. And so the code that we were looking at doesn't look the same, but really under the hood, it just needs to hook into the request at different points. And so that's where we can create our request behavior. Another shorter way of putting this is put by another speaker named Sandy Metz. And she says duplication is far cheaper than the wrong abstraction. So if you go down that wrong abstraction, you're going to end up in that world of pain. You might as well just have deduplicated the code. Cool. So that's step 2. We sort of developed this abstraction. Once we've done that, there may be some tools that we can build that will enable us to take our abstraction and go further steps, right? So what do these tools kind of look like? Well, one is, this one's kind of simple. It's just an empty request behavior. It does nothing, right? You might say, well, why would you want this? Why would you want a behavior that does nothing? I mean, that seems pretty easy to model. But the trick here is that once you have empty request behavior, you no longer need nil. And so if you look at a function like send, you see here that it takes an optional request behavior. Once you can use empty request behavior in that place, that question mark just falls away. And then you can treat all request behaviors as the same instead of saying, well, if it's nil, do this. And if it's not nil, do this other thing. You can just say, I know that I have a request behavior. Just run it. So that's really useful. Another really useful commonality here is a combined request behavior, right? What if we have many request behaviors and we want them to act sort of the same? I'm not going to run through all the code, but basically this has an array of request behaviors, and it knows how to merge all the headers together, and it knows how to run all the before sends and all the after successes and so on. And so again, what is the value here? The value here is that once you have combined request behavior, then you can treat any array of request behaviors just like it's a single object, right? It's a lot simpler. And fortunately for us, we actually do have an array of request behaviors. We can replace that with a combined request behavior, and then you can just watch all the complexity just fall out. And now you no longer need to think about arrays. You no longer need to think about how to merge or how to loop over these things. It's all handled for you. We've taken out a lot of the moving parts here, and the code, yes, it's shorter, and shorter is good, but it's also a lot simpler, right? You never have to think about these situations of oh, what if I have more than one? What if I have exactly one? What if I have 0? Don't have to worry about it. And so our artist with the bull, he continues to abstract, continues to find the lines, and finds the simplicity that comes out of the bull. So that's step 3. Step 3 is to build the commonalities and the tools that will magnify your work, right? And step 4 is to actually do the work of extracting all the things into the little parts. So I'm not going to go through each of our 3 behaviors. I will go through one of them. Here's our auth token header. We only need to override the additional headers part of the protocol. We know we're going to need access to the user defaults because that's where our user token is. We can pull it out, and if it is there, we'll send it along. If it's not there, no need to send anything. Pretty simple, pretty straightforward. Also eminently testable, right? You can mock out your user defaults, and you have exactly 2 paths to test here. The auth token is there, the auth token is not there, right? That's it. 2 tests, and you're done. This code is totally dealt with. You can do similar things with the network activity indicator behavior and with the background task behavior. I won't run through those, they're a little bit boring, but they are sort of there. And so that is sort of step 4 of our process. The last step is the best one, is to enjoy all the benefits that you get from abstracting your code, right? So now that you have this abstraction in place, a lot of things that you never would have done before, which might be useful, but they would have made the code ugly or hard to test or annoying to look at or modify, now they're really easy, right? So what if you just want to log every error? Maybe this logs to a network thing, maybe it logs to OS log, doesn't really matter. But you get to just add this, and you can just pretty much get it for free. This is code that you wouldn't have thought to add before, but now that you have it, maybe it helps you find a little bug because you look at the console and you say, oh, hey, look, this request failed, and now your bug is easier to fix. Here's another one that you would have probably not thought to add before, but now that you can add it, it's so easy. What if we want to time how long our requests take, right? Maybe if we're getting 20, 30-second requests, that means that something's wrong on the server side, we're getting a lot of timeouts. Maybe we just hold off on requests for like 5 minutes. This is really easy to build. Override before send, keep track of the start date, and when the request is done, just figure out how long the request took and pump that into our logger. You can do anything you want with that data, but the thing is that this pattern helps you find things that you never would have done before become a lot easier now. This code before, if we had tried to stick it in our network client, it would have been horrible. But now with this, easy to test, easy to use, super flexible. So why do this again? What did we gain out of this whole process? I think the broad thing that we gain is we gain decoupling, right? So we built strong boundaries between the thing that sends our network code, the thing that sends our network requests, and the things that perform side effects or things that need to happen when our network requests are sent or received or whatever. And once we have those boundaries, we can treat these components that really are separate, we can treat them separately, right? We can handle them in different ways, right? And handle, I mean, that's an interesting word. What do I mean by handle, right? So number one, you can test it. This is a really important part of it. We looked at this earlier. Again, 2 tests is all it takes to test all of this code. And this is done, and you never have to think about it again, right? So I think testability is a huge, huge win here. Another win is reusability, right? If you have this sort of network stack, but maybe you have another network stack somewhere else that handles requests to some other third-party service that you don't control, and you want to be able to use your same network activity indicator behavior, you can wrap that stuff and use your same code again and get wins there. Another situation, maybe you decide you don't like this network stack, you want to move away from it, right? But having this code be separate in a separate unit means that you can use it in both the network stacks as you migrate from the old one to the new one. And the last little benefit that I like here is, it's a little bit harder to describe, but I like that you can just glance at the code and know what it does, right? Tests are really good, but it's also good to just be able to look at something and understand what it does, right? With our error logger, it doesn't take more than a second to look at this and say, I know what this does. I understand this part of the code. Whereas if this is interwoven into the fabric of our network client, you're running through all these little edge cases and conditionals and all this stuff, and it's not as obvious when you look at it what it does. So our artist, you may have guessed by now, it's Pablo Picasso. And he said something. He said, there is no abstract art. And we know that all code is art, so that works great. He says, you must always start with something. Afterward, you can remove all traces of reality. And that's fundamentally what we've done here. We didn't create the abstraction out of nothing. We had working code that we hated, and we subdivided it into these different responsibilities, and then we removed all the traces of reality. Thank you.